Now we're live.
We're live.
We're live. Second period with the big.
Ladies and gentlemen, please welcome to the room.
We're dropping logs all day in here.
Dropping logs.
The giant of math.
The man 4'2", straight out of Michigan. The Wolverine himself, a little Wolverine. Brandon Johnson.
Hello, YouTube followers, all 6 of you. Good to have you here today. We're here live, Precal Chapter 6. We're talking about Conics today, and so thank you, Chris, Sam, and Parker for that lovely
really not a problem.
introduction. Yes, I was scared. I'll be honest. I was very scared. We are getting started here. We're gonna go right straight into our review. We'll start on numbers 1 through 3. If you have a problem on numbers 1 through 3, we'll get that underway, and then we'll go from there. All right. So we'll get that started. Go ahead, Will.
3.
Nominal 3. All right. Let's do it. Number 3 says find the equation of the parabola with a vertex of -3, 2 and a directrix of y equals 5. One thing that I always like to do with this is at least like do a rough sketch of the graph. It always helps me to at least look at it. Now, sometimes people don't do that, and that's okay. But that's kind of how I like to get this started. So, so with that, if we have the equation of the parabola, let's first start by putting where the vertex is. What is the vertex? Anyone know? Remember that?
-3.
Yes. It's -3.
You good?
It's at negative
Yeah, but
3,
what is it in terms of our equation?
H and K.
H and K. Okay, good. So if I were to write this here, we'll go -3, 2. We'll put that right here. We also know that the directrix is at y equals 5. So what is the directrix again?
It's on the outside of the parabola.
Yeah, it's on the outside, right? So if it was going up, we know that the directrix would be low, and then vice versa. Or left and right, it would depend on that as well. So as we look at 5, y equals 5, we'll have our dotted line go straight across. And so that's basically all they gave us. Now, because of this, we know since the directrix is on top, we know that we can then use some sort of equation. What equation would we use in this way?
X minus h squared.
Yeah, let's use that one. Why would it be x squared?
Because it's going up and down. Right?
Yeah, exactly. Because it's going up and down, we know you're exactly right. Because it's going up and down, we know that the x is going to be squared. Left and right would be y squared.
Coach, how did you know it's going up and down?
Great question. Because where's the directrix?
It's on the y-axis.
It's on the y, right? So because it's y equals 5, we know that the directrix, if it's up here, where's the focus? It's going to be on the bottom, right? And we're going to get to that. Now, one other thing too is we know that the distance of P is always what? What's distance P? What's
halfway distance?
Yes, it's half the distance
vertex
between
to
the focus
directrix.
and the directrix, right? Or we could just say the distance from the vertex to the directrix and from the vertex to the focus, right? So because of that, we know that this thing, the P is going to be a distance of what?
-3.
Yeah, we know, and I wouldn't even put like negative. You could, I guess. What I do is I just say, all right, if P equals 3, I know that if this is the vertex, where would my focus be? It's got to be opposite of my directrix, right?
Yes.
So where would that go?
Down 3.
Yeah, go down 3. It's going to be about right in there, right? And so this parabola is going to be going downward because we know the focus is always going, I always say it's on the green, right? With where it's at, or it's always inside of where my parabola is.
Well, you don't necessarily need the focus for this one because you're just looking for the equation.
Correct.
Okay.
Correct. You don't need that, but
It's nice
again,
to know.
yeah, it's nice to know, you know? Just good, useful information. You could tweet about it, and it's great. Okay. So what would be the H and K? Again, someone said it already.
-3, 2.
Yep, -3, 2. Okay, so we're going to put -3 in for H. So it'd be x minus -3. Square that bad boy. P would be 3, right? And K would be 2. Okay, so really all we need is our H comma K, right? Our vertex. And we need what our P is, our distance from our focus to our vertex, or same thing, vertex to our directrix.
On the review sheet online, you had it as -12 parentheses y minus 2.
Yes, yes. So what you said is correct, that P was -4. Here's why I want to be careful, because sometimes people will be like, well, when is P negative or positive? I try not to confuse that. I just say at the very end, is the parabola going up or down? If it's going down, we know that's reflected, right? So we know that with that transformation comes a negative. And so that's just the way that I teach, the way that I go about doing it. I'm sure there's probably a different way where you'd say, yeah, P is -3, but I find that to be tougher. Once I graph it, or at least sketch it, then I know that if it goes upward, it's positive. If it's downward, it's negative.
We leave it like that.
I would simplify it and quite finish up, but it'd be x plus 3 squared equals, what would it be here? What would be the P?
-12.
Yeah, it'd be -12, or yeah, once I multiply by the P, and then y minus 2. And what I do is I'd keep it just like that, and I'm going to allow you to keep it that way for the test.
Wait, why is it -12 again?
Because where's the parabola going? Where's it opening? It's opening downward. So we know since it's downward, it's got to be negative. Same is true if the graph went to the left. Like if the y was squared, left would be negative, right would be positive. Right? Does that make sense? Like if it was with the y. All right, good on number 3. Yeah, Parker.
How many questions do you have?
When I looked at it, I think 7. So it's only 7 for tomorrow. Not too bad. There's going to be great questions because now I've got another thing to tell you. There's only going to be one of them where you actually have to complete the square. You know what I'm saying? All the other ones are going to be ones where I actually give you the equation, you have to figure it out, or one like this. But there's only one where the long way where you have to. If I gave 3 of those, that would be the test. That would be the test. So that's really the focus there. No pun intended. Yep, very good. YouTube followers are laughing now. Yes, George.
Do we have to graph on the review like the first couple questions, or is it just graphed on the solution sheet just like for here?
Yeah, I'm trying to see. Find the equation. Yeah, if you're just finding the equation, you don't have to.
The graph's just there for you to show like how you got there.
That's it. Yeah. I think most of them tomorrow are going to be like that, to where it would probably benefit you to graph them, but that's not a requirement. At least do a rough sketch. That helps every single time. And so anytime you can sketch it, that's always a good way to approach it. Okay? Great question. Numbers 1 through 3, how are we doing on those? We're good. I know a lot of us went through those already. We're good. All right, let's go over numbers. I think we're going 4 and 5. 4 and 5 now. Yeah, 4 and 5 are the next 2 that we're looking at. Anyone have any preferences on that?
Gonna want to start to move things to different sides, X and Y.
Correct. Yeah. So both of those are ones that are going to be like the ones that for the complete the square. I don't remember if the one where we complete the square is an ellipse or a hyperbola, but I remember it was one of those 2. I don't remember which one, but it'll be one of those.
Oh, I see. Preference between the 2. That's what you were asking.
Correct. Yeah. Do we need to do one of the? I'd probably do one of them, right? But is there any? Let's do number 4. Okay. Now, as I look at number 4, other than when it says consider the parabola, kind of gave it to you there. How do I know it is a parabola?
Because it's y squared.
Because there's only one squared, right? There's only one thing squared. X is not squared, so we know it. We can assume that it's going to be a parabola there. So what would be the strategy to approach this problem on number 4?
You move the 8x minus 15 to the other side.
Very good. Yeah, we're going to take it to the other side, right? So if you think about the 8x minus 15, Chris, you said to take the x and the 15 to the other side. Why do we take that one and not the -2y?
Because you want to keep the like. Was it variable?
Yeah, we want to keep that like variable on that side, whatever's being squared. Exactly. Exactly. For a parabola specifically. Now, if this is an ellipse, what do we do for an ellipse? Like on number 5, what would we do there?
Oh, you do the half and square.
Yeah, that's where we would half and square it. Remember, all I'm saying is this. We'll get to that right there, Chris. If it was on number 5, if this is an ellipse, pair the x's and y's together, complete the square, and go from there. All right? Got me on that?
So you don't have to move it to the other side on the other one. You just have to pair them all together.
That's what I'm saying. That's the only difference. Yeah, that's the only difference. So right now we have negative 8x plus 15 on the right, and then what's on the left we keep there with the y. Now, Chris, you already said it. How do I then complete the square? Do I have a half and square? So we take negative 2, half that, and square it. And what will we get for the c? 1. Yep, plus 1. What we do to one side, we do to the other. Very good. So now I've got y squared minus 2y plus 1 equals, equals negative 8x plus 16. All right. Now what do we do on that left side now?
Take it out and, on the left side.
Yeah, because it's a perfect square, right? So we want to get it in the right form. So what we could do is then get y minus 1 squared, because we know two numbers multiplied get me 1, add to give me negative 2 is negative 1 and negative 1. And then we set that equal to, what did we do to the right side?
Take out negative 8.
Yeah, take out that negative 8 because we want that x positive. Very good. So we'll have x minus 2, and we'll keep that as is. All right. Now the next part is this. What is the vertex? What's the focus? And what's the directrix? Well, let's do this. We can graph this. Again, just at least a sketch. What is the center? What's a vertex? I mean, what would be that vertex there? H and K. So what would it be?
Negative 1, negative
2, 1. Very good. Yeah, so I'm going to go right 2 and up 1. So about right in there. Now, is this going to open up or down?
Neither.
Say it again.
True question. Opens to the left.
Very good. Nicely done. How do you know that?
Tricky because the focus is 0, 1. I don't know.
Not necessarily. What is being squared?
The y is.
The y is, right? So since the y is squared, it's going to go left or right. Since it's negative, we know we can assume that, where's it going to go now? To the?
Wait, what's
left?
What's negative?
Because the p is negative, right?
Oh.
Just like we had on the previous one,
Gotcha.
this is going to end up going towards the left. So again, when I draw this out, it'll be going towards the left-hand side, and now we know where, at least the sketch of where this is going.
Wait, so if the y is squared in the original problem, then that means it's automatically left or right.
Correct. Nice. For a parabola, right? We're talking about parabola? Exactly. Good. Good stuff. All right, so what is the p here? How do I solve for p?
Do x equals h minus p.
I think there's an easier way. Yeah, all we need to do is just set 4p equal to whatever that value in front of the value outside of what's not squared, right? Because remember, this is our form. 4p then equals negative 8. Okay, and again, if we get a negative, not really concerned with that. We're just trying to find the distance of p. So if I did that, then what would be the distance of p there?
2.
Yep, 2. So from my vertex, where will the directrix go? Right 2, right? Because it's got to be outside. So we'll have this right here, a dotted line out there. And where will the focus be? Yeah, on the y-axis, right in there, because we'll go 2 to the left. Remember that distance here is the same as the distance here. P is just the distance between the vertex and the directrix, and from the vertex to the focus. That distance is going to be the same. Okay? So, did you have a question?
No, sir. You just answered.
Sweet. So, what would be the focus point would be where?
0, 1.
Yep. So, focus is 0, 1.
Directrix is x equals 4.
Yep. Directrix is x equals 4. Good.
Directrix is like the whole distance.
Yeah, that'll be because it's a dotted line there. Okay. That's a line. So we just say that as x equals 4. This would be the focus there.
You want the like x equals 4. You don't want like 4 or 1. You don't want a point, right?
No point. Yeah. Only the focus is what is represented as a point.
Coach, how did you get the directrix?
Well, first of all, we know where the vertex is, right? We know where it opens up. It opens up left. We know that the directrix is always outside of the vertex, right? So we know that it's outside of it, but it's never inside of my parabola. So if it opened up to the right, you'd flip-flop where the focus and the directrix would be.
Okay.
Correct? So that, and again, that distance is the same as the distance from the focus, the vertex. And how do you get that distance? Because I have a value of 2.
Okay.
SB. That makes sense?
Yes.
All right, all good? Do we need to go over number 5, or are we okay?
Yes.
You want to go over number 5? Perfect.
Can I just question really quick?
Yeah, go ahead. Was it in this class that last time? No, I think it was. Where you had to have a bathroom break in the 45-minute class or something?
No, you told us about that.
Yeah, I was like, oh my goodness. We know we're seniors when. All right, so let's do this. Let's go number 5 here. This is a good one because, again, this is one that would be what would be comparable to what will be on the test tomorrow. All right, so since it's an ellipse, we know that both x and y will be squared. Now, we want to keep everything on the left-hand side except the value that is by itself. So that 37 that is on the left-hand side, let's move it over to the right. So when we end up putting everything together, it should look like this. It should be 4x squared minus 32x, and then plus 9y squared, plus 18y, and then equals negative 37. All right? Check me on that, but I believe that should be correct.
Looks good.
All right, so we're pairing x's and y's together, very similar to what we did with the parabola. The only difference here is that we've got to be able to complete the square on both x and y. How would I do that? What would be the first part of doing this?
Factor out.
Yeah, we're factoring out what?
On the left, we'll factor out.
Good, and then what about the y? Yeah, we'll factor out a 9, right? So we're going to factor on the left and the right to get x squared minus 8x. And really, I should have left the blank here, because we're going to complete the square there eventually. Plus 9 times y squared plus 2y equals negative 37. Okay? All right, so what do we do to complete the square? Half and square it again. Good, so with negative 8, we half and square it. We get what on that first part?
Plus 16.
Plus 16, good. What about the next part?
Plus 1.
Yep, good, very good, Chris. Now, what do I bring to the other side? Do I bring 16 and 1?
No. Yep. No, you multiply it by the number of the outside.
Exactly. You got to make sure you, because really it's 16 disguised as 16 times 4, right? 64, right? Really, it's disguised as 64 because of that 4 on the outside. So we're going to add 64 to the right. And what about this 1? What would that be? Yeah, plus 9. Good. So when I add 64 and add 9, I'm kind of running out of room here. What would I do when I complete the square with the x now? What would I get? What would be the perfect square there? I think it's x minus 4, right? X minus 4? So I have x minus 4 squared. And what about the y? Y plus 1. Good. Very good. Equals, see, Miss Wilson? And once I end up then putting that together, negative 37, 64, and 9 get me what?
36.
36? Bingo. Nice. So once I do that now, I'll divide by 36 on both sides to make sure that we get it in the correct form where it's equal to 1. And I'm actually going to bring it up top here because I ran out of room. But I should have then x minus 4 squared all over 9 plus y plus 1 squared all over 4 equals 1. Is that what you got?
Yep.
Excellent. All right.
Beautiful.
Butamus. Awesome. Amazing. So what would be the center now?
4, -1.
Yeah, 4, -1. So we'll bring it down yonder on the Chattahoochee. But I learned how to swim. A lot about living. Very good. Nicely done. So I can't believe I just did that on YouTube. So once I end up then solving for that, what would be my axis for my x? What would be my a and b? We know my a is, yeah, a would be a total of 6, right? A would be 3. B would be 2, right?
Why?
Because when we square rooted, right, it would be 3 is A, B is 2. But you're right, Sam. You said 6 because you have to double it. So the total distance.
But didn't you put 36 underneath?
Yes, but remember that this 4 goes into 36
I
9
see.
times, right? So this right up here, yeah, make sure YouTube followers, when you follow me here. This right here is the simplified version, okay? So this X, we should go left 3. I think that's 3 there. 1, 2, 3. Right 3, and then I should go up 2 and down 2. And you might say, why is that? Remember that the B is underneath the Y. So that's why we'd go 2 up and down and 3 left and right. So that's why this right here would be the ellipse graph there. Okay? And does it say to graph it? No, it says just the center. We know what the center is. That was easy. What are the vertices? You sure?
Major points.
All the major axis points. So it should be like 1, -1 and 7, -1, correct? All right, those are vertices are only with the major axis, right? And then the next question was, what are the endpoints of the minor axis? Well, that would be, that's 4, 1, 4, -3. And then finally the foci, that's kind of the tough part, okay? Because now we know the foci are inside the major axis, and again, remember the foci are always inside the major axis. So what you can do is take the 4, -1, and since we know that the major axis goes left and right, the only thing that will be changing is what? The X, right? Very good, Chris. So the only thing that's changing is the X. So with my 2 foci, 4, -1, we can rewrite both of them that way, but the 4 is going to stay put where the -1 is going to be changing. Does that make sense? Because the foci go left and right inside of my major axis. How do I know what I'm going to add to -1 though?
Wait, isn't it
Go ahead.
the -1 state
Yeah, there's no one.
in the fortune?
Oh, yes. I apologize. So we'll just say this. What's circled, I apologize. I messed up. I said that right, or Chris said it right, but I messed it up. 4 is what's changing because 4 is on the X. Very good. So when I find what my C is, that's when I'm combining, adding, and subtracting to my X. Very good. So how do I find what my foci is?
You just go halfway.
Exactly. A squared minus B squared equals C squared. And what you can do is on your formula sheet, you can write that in. I will allow you to use that. Underneath the ellipse, put A squared minus B squared equals C squared. And again, that will help you to be able to solve for what that C would become now. And you could write that in. What would be, side note, what would be the hyperbola one?
A squared plus.
A squared plus B squared. You could write that in there too. And I'll allow you to use that on the test as well. So ellipse and hyperbola.
So it would be plus or minus 5.
Good, yeah, Chris, very good. Because now we know that A squared is 9, B squared is 4. So 9 minus 4 equals C squared. Where if we square rooted it, C would be equal to plus or minus square root of 5. And so once we go up here, what we can do is say, for our foci, we could say 4 plus square root of 5, comma -1, and 4 minus square root of 5, comma -1. And that right there would be your answer. Okay. On the test, I do ask, I give a blank for each. So I say, all right, what's the foci? Give it to me. What's the major axis? Give it to me. What's the vertex? Give it to me. So I try to make sure I went through that and help you out there. Okay? Yes, Toots.
Coach, are the polar things going to be on the test?
Great question. If you go back there, I'm going to go on number 14. I know it's harder to see on 14. 14 and 17, you can cross off 15 and 16.
Oh, we do.
Yes, 15 and 16 cross off
On the review.
on the review. Okay?
Yeah, no one likes
Before class ends, can we do one of those?
Yeah, I can do it now.
Wait, so we
I can do
are
that.
doing 14 and 7.
14 and 17, you'll need to know how to do. Correct.
Wait, what?
Do you do one of those?
Yeah.
Absolutely.
I don't know.
Yeah.
Actually.
So let's do number, we do number 17. Right.
Okay.
Once I go through one, remember I touched on it on Thursday, but I know it's been a little bit. So we'll do that and we'll go from there. All right, 14 says this, 0, -4. Now, with 0, -4, it'll give us a point, and they're wanting us to put it into polar. Okay, remember polar, we have two things. We have our magnitude or our hypotenuse and our degree. So I put my distance and my degree, okay, or my direction. Now you might say, well, I don't get that. Well, let me show you, and I think it'll make sense. If I looked at this right here, 0, -4 would be a point that was down yonder, okay? So 0, -4 would be right here, and what would happen was it would be like literally as above here. This distance right here would be from 0 to -4. But when I end up putting it into polar form, my question is what is my magnitude here? Meaning, what is my distance? Now, this one's pretty easy, right? Because that one, you don't have to use sine and cosine. Normally, if you had one that was like, let's say it was 3, -1, and it was down here, and it was like a line that went through there, we would have to use sine and cosine to be able to find backtrack with me. We'd have to use inverse tangent to find what the angle is, and then use Pythagorean theorem to solve for what the hypotenuse is. Now, here's the reason why. For 0, -4, you don't have to solve for that. All you need to know is what's that distance, which would be what? We just put it as positive because distance is positive, right? We just say 4. And because of the angle, we actually don't even need to do inverse tangent. Why? Well, because it's going straight down. What would be the angle on this? Going straight down.
Where's your triangle?
Say it again.
Where's your triangle that you're trying to solve this?
At 0, -4? It's actually not a triangle, is it? Look at it.
Where'd you get that line?
It's just a line.
It's this one right here. That's all it is. Because is there a change on the x? There's no x, right? It's just 0 to -4.
What's the 0 to pi?
That's
0
just
to pi.
telling you like your.
It just got to be between there, between 0 and 360.
Coach,
So it falls right there.
where'd you get that line you just drew?
Right here, over here on this side, I just was showing you like if it was 3, -1, right? Or this is 4, -1. What I would do is to solve for the hypotenuse, I do 4 squared plus 1 squared equals c squared, right?
Yeah.
To solve for what the distance is. Here it was easy because I could just see it, just a line. Here, not so much because it's actually the hypotenuse.
Okay.
So it would be, if I were to do that, it'd be like square root of 17 when I did the Pythagorean theorem. So then I would have that, but then I also have to find what that angle is, and I do that by doing the inverse tangent of opposite over adjacent. Now, why don't I have to do that here? Well, I know if it's going straight down, it'd be what distance from the 0 degrees?
270.
270, which in terms of radians, which is what we want, would be 3 pi over 2. So what we would do is say 4 comma 3 pi over 2. Okay? And that would be our answer. That's changing it into polar.
Could we do one of these that's more complicated?
Yeah, like number
Yeah.
17 might be a little bit different. Number 17 is one where you actually have to do it backwards now. So if we were to do this one, 3 comma 5 pi over 2. 5 pi over 3. Thanks, Chris. Yeah, right when I said that, I was like, what am I doing? 5 pi over 3 would be where? What
300
quadrant?
degrees.
Yeah, it'd be 300 degrees, which would be about right in there. That's good, Sam. So if that's 300 degrees, okay, think with me for a second. What would be the angle that was attached to the x-intercept?
60.
60 degrees, right? We call that reference angle, if you remember that. Reference angle. So we're going to put 60 degrees right below. And to answer your question, Matthew, remember the triangle? That's how the triangle was created right here. Okay? The only difference now is that I give you what the hypotenuse is as well as the angle. That's it. So now you're trying to find what the x and the y is to put it back into rectangular form. Right? So right now we've got 60 degrees here. And this hypotenuse we know is 3, right? That's a distance of 3. Now, since this is 3 and this is 60,
Is
Go
your
ahead, you're good.
hypotenuse always the x? How'd you know?
in polar form, yes.
Okay.
Yes. Remember I was talking about like when I dance, right? When we do it, when we dance or whatever, we have two things. We have direction, we have distance, right? that distance is as if I started at the origin and went this way. But then you come up to me in the middle of the dance at prom. In fact, I had like 3 or 4 people that were curious about this come and ask me in the middle of prom, Coach, if you dance that distance at that angle, really how far, if you just went left and right, how far left and how far down would you have to go? And I said, thank you for asking me. And I took a napkin out and started drawing, and it was great. It was awesome.
That's why I
And then
didn't see
afterwards,
you
they
dancing.
didn't have a date when they came to prom, but they did when they left because of it.
Yeah.
It's funny how things work out that way. So what we could do is just say this is X, this is Y. So to solve for them, it's not very, very difficult to solve for them because all we're going to do is sine of 60. And by the way, it follows the same pattern. Sine of 60 equals opposite over hypotenuse. But what's the hypotenuse? 3, right? So if I multiply by 3, I could have 3 sine of 60. And how do I find the adjacent side? 3 cosine of 60. Good. All right. Equals adjacent. Go ahead, Stephen.
Okay, so the first number in that is always the hypotenuse, right?
Yeah, obviously. Yes.
Okay, so just making sure I understand like this whole concept of it, right?
You're exactly right.
Yeah.
So we
Okay, I'm thinking about it. Yeah.
You're gonna do both because then the
Yeah, I'm getting
adjacent
it.
side will be the X, right?
Yeah, because 3 pi, and that's the angle. I got it now.
Good to
I
go.
was lost. Now I get it.
Hey,
Coach,
that's right.
you could also do it with the 30 degrees,
No.
correct? And just do
300 degrees.
no the 30
One's
degrees.
blind. Now,
So you right now you're using 60, 30, 90.
Yes.
You could at the vertex use
You
your other
could use this
triangle.
angle right here. Yeah, you could.
Well, no, I mean yeah,
this
that
one
one.
right here. You could. Yes.
Okay.
Yes.
So how would you write your final answer?
So what's the sign of that? What's the sign?
2.6.
2.6. And what about cosine? 1.5. So what I do is I look at it. I literally stare at it for about a good minute, just to do it. Okay. To intimidate the problem. I love that. That's great. Yes. So I
The
stare it
numbers
down.
start changing.
Exactly.
Exactly. Easier.
So the X would be positive because it goes to the right. That made my day. X is positive, so because that's the adjacent side, we'd have 1.5. And then the Y would be negative because we're going down. So we're going to make that negative 2.6. So we could leave it as 1.5, comma, negative 2.6. And I leave it as that. Now on the answer sheet, when you look at that, it's going to be a little bit different. It's going to be off because of just the way that they did it, the way they approached it. I taught it this way, so as long as you keep it as a decimal, you're okay. Out of the 7 problems, you'll have 1, and I believe it's linked to this one, I believe. Still want you to know this one just in case, but I think it was one very similar to this. Okay? Well,
Coach.
Yeah.
We don't get any kind of like notes or anything like that on the test.
what other? Yeah, I think the formula sheet's pretty good. What notes would you need on that? Because
What
I
if our
just didn't
pamphlet's
think about
done?
what's that?
What if we get our pamphlet done?
If you get your pamphlet done, you can use it for the test.
Okay.
Woo! Sound good?
Yes, sir.
That fair enough? How about this? Got to be completely done. Can't be halfway done. Does that sound okay? So if you decide that, you know what, tonight, and now if you do that, tonight's gonna be bare because you got to review and the pamphlet. But my idea is if you do both, you're gonna be ready to go for the test. Is my idea because you'll be practiced up. Okay. Hey, this is Coach Jay coming out to you. Hopefully, all is well. Again, thank you, YouTube followers. Thank you, Precal students. Have a great day. This is Coach Jay signing out. Bye.